Nuclear decay is what happens when a large, unstable nucleus emits either energy or mass in an attempt to become smaller and more stable. There are three kinds of decay that you need to be familiar with: alpha, beta, and gamma decay. Each form of decay emits a different amount of mass and energy. Alpha decay is what happens when a large, unstable nucleus emits an alpha particle. An alpha particle is essentially a helium particle, which means it has 2 protons and 2 neutrons. The 2 important facts you need to remember for alpha decay are: first, the total loss of mass is 4 atomic units. Second, because we're losing protons, the element actually changes. So in this case, we start off with plutonium, but then plutonium shoots off a helium particle, 2 protons, 2 neutrons. 2 changes happen. One, our total number of protons in the atom has changed, so we're no longer talking about plutonium, now we're talking about uranium. Also, the total atomic mass has dropped by 4. Beta decay is a lot different than alpha decay. In beta decay, there's actually no change in mass. Instead, in beta decay, protons and neutrons are just changing place. There are 2 kinds of beta decay: beta minus decay and beta plus decay. In beta minus decay, we start off with a neutron, and you could think of a neutron as having both a positive and negative charge. In beta minus decay, the negative charge actually shoots off, so we lose a negatively charged neutrino. What's left is a positively charged molecule called a proton. So if we look at the total mass before and after beta decay, the total mass hasn't changed. But if we look at the atomic number, that is the number of protons, that number has gone up because a neutron became a proton. In beta plus decay, we start off with a positively charged proton, and then that positive charge is emitted in the form of a neutrino. And since the proton has lost its positive charge, we simply call it a neutron. Again, in beta plus decay, the total mass hasn't changed, simply the number of protons. In this case, the number of protons drops because we have a proton transforming into a neutron. In gamma decay, there's no loss of mass and no protons or neutrons changing place. Instead, all that's emitted is a high-energy electromagnetic wave. If you see a question talking about gamma decay, simply remember there's no change in mass. Here's a nuclear decay problem that's very similar to the type you're likely to see on your exam. So we start off with this radium nucleus that has a mass of 224. Then the nucleus undergoes alpha decay, which means it emits an alpha particle which has a mass of 4, 2 protons, 2 neutrons. Now the mass of the nucleus drops to 220. We know the velocity of the alpha particle going to the right, and the question is asking us what's the velocity of the remaining nucleus going to the left. This is simply a recoil problem, which means momentum in the system is going to be conserved, or the mass times the velocity of the nucleus going to the left will be equal to the mass times the velocity of the alpha particle going to the right, or a mass of 220 times a velocity that we don't know yet is going to be equal to a mass of 4 times 10 to the 7th power. The MCAT answer choices are usually geared to allow you to do some estimation. We could rewrite the problem as the velocity is equal to 4 times 10 to the 7th, and I'm just going to change 220 as 200, or 2 times 10 to the 2nd. My 4 and my 2 simplify to just be 2, and I subtract my exponents on the right, so I'm left with 10 to the 5th. And that is the velocity of the nucleus going to the left. Let's try one more. This time the question is asking us what kinds of decay could bring us from bismuth 210 all the way down to lead 206. The first thing we should recognize is that we're losing mass, and the only form of decay that reduces mass is alpha decay. Gamma decay and beta decay don't change the mass of the nucleus. When we undergo alpha decay, we lose a total mass of 4, and that matches the drop from 210 down to 206. However, if you look at your periodic table, lead has just 1 less proton than bismuth. And in alpha decay, we actually lost 2 protons. So we're going to have another decay, something that would allow us to add a proton without changing the mass. And that's going to be beta minus decay. In beta minus decay, remember that we start off with a neutron, something with a neutral charge, and then the negative charge is emitted, leaving a particle with a positive charge, or a proton. And that allows us to add a proton without changing the mass. So with alpha decay, we lost 4 atomic units, 2 protons, 2 neutrons. That was 1 proton too many. So to get a proton back without changing the mass, we converted a neutron into a proton through beta minus decay.